Hello everybody and welcome to my presentation. Before I start, I would like to thank the team organizing PyDay Barcelona 2020 for inviting me to speak in this event, and especially to you for listening to this presentation. Today I'm going to be talking about documentation-driven development for Python web APIs. Before anything else, I would like to introduce myself to you. My name is Jose. I work as an independent contractor in the UK. I usually work as a full stack developer, usually with Python and JavaScript, and for the past few years I've been working extensively with microservices and APIs. I like to think that as a consequence of this work, I've possibly made all the mistakes you can do when working with microservices and API integrations. Kind of as a consequence of this experience, I got this idea to write a book about this topic. The title is Developing Microservice APIs with Python. It's been published by Manning and it's currently available through the Manning Early Access program. We currently have 2 chapters out, and we will be releasing new chapters every few weeks until it's fully published. If you want to buy the book now, you can use this discount code to get a 30% discount from the price. You can reach me out through different platforms, and please do. You can find me in Twitter, GitHub, Medium, and LinkedIn. So if you want to connect with me, you can use any of those platforms. And so what are we going to be talking about today? I'm going to explain what is documentation-driven development and why it matters. I'm going to show you how you put documentation-driven development into practice with a simple example. I'm going to use the example of a simple REST API. I'll be starting from the OpenAPI specification for the API. Then I will show you a simple implementation of the API using the Fast API framework, and I will use Dredd for testing the API against the implementation. I will show you how you can use this approach together with your continuous integration system to make sure that any changes that you make to your API, intentionally or not, don't break the specification. And we will deploy all of this to Haro. So we have a lot of things to do, so let's get started. You can access the code for this presentation and in my GitHub account and the PyDay Barcelona 2020. If you can't get hold of this URL right now, ping me through one of the channels I mentioned before. I'll be happy to share the link with you. So what is documentation-driven development? Well, this is an approach where you write the specification first for the API and then use the specification to validate your implementation. This is an approach that is sometimes called API first, emphasizing the idea that you first design the API and then you make your implementation against it. To illustrate why I think this approach is important, I brought an illustration here. So usually when working on APIs, we have a backend team working on the server side of the API, and normally we have a front-end team working on the consuming side of the API, which is typically a front-end application, although it can be other kind of application as well. So in the best of cases, we will have both teams working simultaneously on the implementation, and then at some point we will release the server, then release the client code, run some tests, and boom, everything falls over. And this can happen for multiple reasons. It can be a bug in some way in the server that has nothing to do with the API. It can be something that happens in some bug in the front end. But more often than not, it is something related to the API. It's usually the case that the front end code is expecting an API that the server is not exposing, or the other way around. Very often this is due to little details where the API server and the consuming application are not in agreement on the format of some field. For example, it may be the case that the server is expecting an ISO date using dash as separator for the values. It's possible that the front end is sending the ISO date using slashes to separate the values, and this leads to an integration failure. And it's a pity that sometimes our integrations don't work because of small details like this. And if we don't have a robust approach to validating our implementations, then it's sometimes very difficult to catch these small bugs. Now, experience kind of tells me that there is like a fundamental law of API integrations, which is that no API server survives first contact with its client. And documentation-driven development may not prevent this, but it will definitely help to reduce the chances of failure when integrating the server with the client, and it will definitely help us catch any issues related to that integration. In this regard, I would like to clarify a few ideas about what counts as API documentation. When working with different teams, I've seen different situations of people using tools like Google Docs or SharePoint or Confluence and similar means to produce API documentations. Now, this is not necessarily bad. It's definitely better than nothing, but it's definitely not enough. And it's not enough because the existing tools in the ecosystem of documentation-driven development can't use these tools to generate tests for our implementations. When it comes to APIs, we have to use standard formats. When it comes to REST, that is Swagger or OpenAPI. And if we are using other types of APIs like GraphQL or gRPC, well, those technologies already offer an approach in which we have to define first our APIs. In the case of GraphQL, we have to define the queries and the attributes and the objects that we can query by using schema query language. And in the case of gRPC, we have to define our data structures using protobuf files and generating our client code using the protobuf CLI. There are a number of misconceptions about API development that I've heard over the years and I would like to address. The first of them is that we can't start working on the client application until the server API is ready. This is not the case if we have the specification from the start. If we have the specification, we are able to undertake the API server implementation and the client at the same time, and we can be fairly certain that both sides of the API will integrate without much trouble. Another misconception that I've heard many times is that API changes should be driven by the backend. This is definitely not true. As a matter of fact, we should be implementing our APIs with our consumers and clients in mind. Our purpose when we implement backend applications should be to make it easy for our consumers to use those applications, and the same goes for APIs. When we make changes to the API, it should be with the client or the consumer in mind to make it easy for them to use the API. Another misconception is that the backend is the source of truth when it comes to APIs. Well, the backend offers the implementation of the API, but that's not necessarily the source of truth. The source of truth is the specification. The implementation in the backend may be wrong with regards to the specification, but we should always check against the specification and not just the backend. Another misconception that I find often is that documentation, and in particular documentation-driven development, is only needed when you are working as an API vendor and you have clients which are external to your organization. Now, in that case, you definitely want to use documentation-driven development. You don't want to make any mistakes in your API implementation, but the same approach can have lots of benefits within your organization by allowing multiple teams to work in parallel but separately or independently on both sides of an API. The situation that I've been presenting so far is a simple case of a backend API integrating with a front-end application. But oftentimes we may have more complex scenarios, such as, for example, when we are working with microservices. In this situation, we may have a service A, which has integrations with services B and C, and service B may have integrations with services D and C, while service D talks back to service B. In situations like this, it's definitely not beneficial to think that we should wait for any of these backend APIs to be ready before we move on to the next. Because in many cases, communication works both ways. Service B needs to talk to service D, but service D needs to talk back to service B. So in situations like this, we can't wait for one or the other to be ready. Both of them rely on each other, and we should be able to work on them in parallel. And documentation-driven development helps us with that. Now, this is enough theory. Let's move on to the code. So, like I mentioned before, you will be able to find the code for this presentation in my GitHub account under PyDay Barcelona 2020. Let's start from the OpenAPI specification for this API. So this is a very simple API for a to-do management application. It contains 5 simple endpoints, which we can use to retrieve a list of tasks, to create a task, to get the details of a specific task, update a task, and to delete a task. I've also included 2 schemas for the API. One of them is to create a task, and the other schema is what we can expect from the API when we retrieve the details of a task. Now, using YAML is fine, but I guess it's always better to get some visualization in a Swagger UI. So one website that I like to use for this is Swagger Editor from swagger.io. In this case, we can paste the API here, and first of all, if there are any issues with the API, the website will tell us. So if we replace this boolean by a string, we will get a validation error. Let's put it back to a boolean, and here is so much easier to see what the API looks like. So like I said, we have 5 endpoints, and we have 2 very simple schemas for our tasks. Like I mentioned before, I've made the implementation using Fast API. For those of you who don't know, Fast API is a fast-growing API framework for Python. It's a highly performant web server framework as well. If you have some experience with Flask or Django, you will find it has a very similar look and feel to those frameworks, in particular with Flask. Getting an instance of a Fast API application is very simple. We just create an instance of Fast API. We define our routes, in this case in a different file, using decorators like in Flask. And something which is cool about Fast API is we use Pydantic to define our schemas. Pydantic is a very cool Python library for schema management, because you can define your validation rules using Python type hint. So it looks and feels like more modern Python. But I'm not going to write the schemas by hand myself. This has been generated with a library directly from the specification, and I'm going to show you how to do that. The dependencies for this application are listed in the pip file in the GitHub repository. You can install the dependencies from here. I'm using Python 3.7 in this case, but you can use any other version of Python that you like better than that. Like I mentioned at the beginning, we are using Dredd to run our tests, and I'm installing a Python plugin for Dredd, which allows us to write hooks for Dredd in Python. I'm also using Data Model Code Generator, which is a library that allows us to generate Pydantic schemas from the specification. Obviously, I'm using Fast API. I'm using Ubicon to run Fast API. API star is a very cool library that you can use to generate Swagger visualizations of your specification files. So let's see how this works. The first thing I want to do is to generate the schemas from the specification, and to do that we run this command, data model code gen. To this command you simply need to pass the path to the OpenAPI specification file where the schemas that you want to use are written, and you pass the path to the file where you want to output the schemas, the Pydantic schemas out of this process. So if we do that, that's going to create a file. I already had this file created, so it's not producing significant changes. It's just creating the timestamp and a model for an error schema that I had deleted before. So with this, we are ready to run the API. Let me show you what this looks like. So like I said, I'm using Unicorn to run the app. We simply need to pass the path to the application object, the instance of Fast API that I mentioned, that I showed you before in the app.py file. So with this, we can get a visualization of the API. Under docs, we're able to see a Swagger UI for the API, and we can use this for testing. So if we try out the endpoints, we haven't created anything yet, so we can create a task first. Let's say this is making a presentation for Barcelona PyDay 2020, and sorry, this should be the task, and the status is pending. So if we send this to the server, we have created a task. If we list the tasks in the API now, we see that the task has been created. Validation works as per the specification, so the statuses that we can specify are pending progress or completed. If we specify something else like ASDF, we will get a validation error, an unprocessable entity. That's cool. Now, we could test this manually and look for all possible edge cases and all of that, but because we have the specification already in place, let's do better than that, and let's use Dredd to run our tests. Now, Dredd is an npm package. To install Dredd, just run npm install Dredd. I'm not going to do that because I already have it installed. And to run the tests, in principle, the only thing we need to do is run Dredd. Let me remove the hooks file because I haven't mentioned that yet. So we, in this case, I'm just specifying the path to the specific binary file of Dredd. The first argument is the OpenAPI specification for the API. Next thing is the server, well, the host where the our application will be running by default, so that Dredd can execute tests against the server. The language argument is only needed if we are using the hooks, so let's remove that now. And the server argument is an instruction for Dredd to know how to set up the server for testing. So if we run this, it will run the test against the current implementation, but because we don't have any data that can be used by default for testing, not all of the tests are passing. We have 5 passing tests and 3 failing tests, and those 3 failing tests are related to the specific resource of the task that should exist in the server in order to be able to update it or delete it. We don't have that, so for these we're going to use Dredd hooks so that we can make sure that there is a task in the server by the time the that by the time that Dredd is hitting those endpoints. What do Dredd hooks look like? It's very simple. We define them as decorated functions where we specify the path to the specific situation that the server will test. So for the path to do, which is the generic resource for our tasks, there is a description for this endpoint, which is create a task. Right, for this specific part of the API, we are telling Dredd to make sure it captures the payload returned by the server when we create a task, save the ID in a global object that is defined here, and when it comes to these endpoints that are targeting a specific tasks with a specific IDs, we are going to tell Dredd use the ID that was returned from the server when you created a task. Using these, the 3 failing tests that we had before won't be failing any longer. Let's see how that works. So this is the extended command. We are telling Dredd where it can find hooks to customize its behavior and what language we are using to define those hooks. So if you run this command now, excellent, all tests are passing. I just noticed recently, I've been using this library for a while, and I just noticed recently there is this bunch of errors which are raised at the end of the test. I don't know very well why. It just happened very recently, but it's not affecting it's not making the tests fail. It seems to be a warning. Right, so the tests are passing here. Let's make a change to the OpenAPI specification, and let's not change the implementation. The test will fail in that case. I have created 2 tags for this presentation. One is a tag where we have the OpenAPI specification without the priority attribute. The other tag is where we have the OpenAPI specification with the priority tag, but I haven't updated the implementation to account for this new attribute, so the tests will fail. So let's check out into that tag. Let me undo the changes first that I have here. Now, the OpenAPI specification now has the priority property that I mentioned before. It accepts only 3 values: low, medium, or high. And let's see what happens now when we run the test. Right, so 3 tests are failing, and it's exactly those tests where we retrieve details of a task. You can see here what the error is. The priority property is missing from the payload. Now, if we commit this, if I make an empty commit, so if I push this branch to GitHub, the CI will trigger a build for this. I'm using Travis for this integration, and as expected, the tests are failing in Travis. So to fix this, we simply need to use the code generator library to generate the new schemas from this specification. So let's go ahead and do that. This will show the diff in the schema files. We are adding the priority property, which we just added to the specification. So let's go ahead and commit this. And Let's go ahead and push this directly to master because we are running short of time. So Travis will test this new feature, and the tests will pass because we updated the schemas. And as expected, the tests are passing now in Travis, and because of that, it's triggering a new deployment process in Heroku. So we can go and see that in the Heroku app. So as expected, the tests are passing, and this has triggered a new deployment to Heroku. The build has already finished, so we can go ahead and see what the result of this is. And there you go. This is the newly deployed app with the updated schemas, with the priority fields. We can test this just as we did locally. No task has been created yet, but we can go ahead and create one. There we go, we created one. So if we list the tasks, we see the task we just created. And that's all there is to it. Thanks so much for your attention. If you have any questions or comments on this presentation, please let me know. Thanks again.